putting it all together. Okay, so now we want to find the exact values of all the roots of this function here. Okay, so when you're given a problem like this, and you're going to be given problems like this, on some quizzes for chapter 2, on a quiz for chapter 2, you're going to given a question or two like this on the first exam you're going to have. You're going to be given a question like this on the final to do. So this is not going to go away anytime soon. And WebWork has some problems that work around this kind of thing too, but they have you just do pieces here and there. I want to find all the roots. So let's go through a process that lets me systematically figure out what I need to do to get them. First of all, I look at the degree of this polynomial. Now, if it's not already written in standard form, which means from highest power of x down to lowest power, it's a good idea that you do so yourself. Okay? Since the highest degree here is 4, I'm expecting to have 4 roots. And so what I'm going to do is I'm going to first graph this thing. And here's a graph of it would look like on the TI-84. It's a more modern version of the TI-84 that I'm referring to here. I'm showing the graph. Basically, I typed in y equals 4x to the fourth minus 4x cubed minus 51x squared plus 3x plus 36, which you see up there. I just don't have it. I don't have a window where I showed it. That's what I typed in. In the window, I set my x's to go from negative 10 to 10, the scaling to go by ones. That's what it means. So it means that each tick mark as I move from left to right represents 1 unit. For the y's, and this is usually done through some trial and error, but just by looking at what you have and trying to get the graph to fit. The zoom features, I would say try to stay away from those because sometimes if you zoom out far enough to see the highest and or lowest points, sometimes the graph gets so crammed together horizontally that you're still going to be missing some things that you need to see. So make it a point to maybe just like play around with your y values and x values yourself and try to get the graph to fit yourself. But I chose a y minimum of negative 300, a y maximum of 100, and the scaling to be by 10. And I guess lets me see what the picture is, and I can see all 4 roots here. So I don't have any multiplicities going on here that we just talked about. I have 4 separate roots. It's a degree 4 polynomial. All the roots are real. It's just whether or not are they rational or irrational. So I'll eventually use the calc menu, and I can show you more of that in class if necessary. Originally, when I made the video that you're watching, I didn't really have the ability to switch back and forth between views because the recording software I had didn't really allow me to do that. But now that I'm redoing the video, or at least re-editing it, I can now put this part in so I could show you here how to use the calculator to find these zeros. And as mentioned in the video prior to this, there are 4 zeros here, and I did show you what these were, but how did I get them? So basically what you're looking to do here is once you have the graph set up, you're going to go to your calculator here, and above the trace button you see calc, and you're going to hit second and calc. That takes you to this menu here. 2 is to find a 0. So what you want to do is just you want to choose either hit the number 2 or scroll down to number 2, and you can see where the cursor is. Usually it's going to ask you to find a left bound and a right bound. So basically you want to put an area that's going to have that one and only 0 in between them. So say I was looking for this one here, which ends up just being negative 3, but you could either move the cursor by going left and right like this, or you could just type in a number. Since this looks like it's at negative 3, I'm going to choose negative 4 for a left bound, so I definitely have this occurring to the left. And I'm going to choose negative 2 as a right bound. And so that I'm looking at a region of the graph where there's only one possible place for the graph to pass through at a certain point. I don't want to have 2 of these zeros in my region because it's just going to go to one or the other. Sometimes you don't really have as much control over that at all. If you do this the right way for your guess, you can put it, you can say, well, negative 3, you can put it there, or you can just leave it alone. And I hit enter, and you can see the 0 is at x equals, so that verifies it. So looking for this one here, just to show you one more example before going back to the video itself, I'm going to hit second and calculate. I'm going to go to 2 for 0. This one looks like it's around -1-ish, maybe a little bit before it. So just be on the safe side, I'm going to make my left bound -2. I'm going to make my right bound 0. And as far as the guess goes, again, it doesn't really matter since I only have one value in between these two where it crosses the x-axis. And I hit enter, and I get the -0.8660254. And sometimes you might see this come up. It won't be 0, but it might be a very small number written in scientific notation. You'll notice that with an E and a relatively larger size negative number following it. That's kind of the same thing as a 0. So if this is giving you a value here, that's letting you know that this is a 0. It's probably irrational because it's decimal, no repeating patterns seen here, it doesn't terminate. So this is one of the ones you're going to eventually have to do the other methods to find the exact value of it. Now back to the video. I get -3, -0.8660254, 0.8660254, and 4 as being the values of where those x-intercepts are. Obviously, the -3 and the 4 are rational. The 0.8660254 and its negative counterpart, when I see that 4 at the end, it's probably because of a rounding. It would probably keep going on forever with no particular pattern that's developed there. Those are probably irrational values, and I'm going to have to find the exact values for. So I now have my two rational roots. I want to find the exact values of my irrational roots. So I'm going to use synthetic division to break this function down. I already know what the result's going to be as far as the remainder goes. I'm going to get 0. So first I apply the -3. I do the synthetic division with that and the polynomial expression to do its coefficients. I then apply the 4. And I end up with, a final result after the two quotients are done together of 4x squared plus 0x minus 3, which means I can factor f of x into x plus 3 times x minus 4 times 4x squared minus 3. By the zero product property, I have three quantities multiplying together to give me 0. One of those quantities has to equal 0 for that to happen. That's why that setting equal to 0, because this is ultimately a method of factoring. Okay, it's a method of factoring. If you remember back when we talked about quadratics or even the quadratic formula, because the quadratic formula kind of has its roots from factoring as well. The reason why we have to set it equal to 0 is because ultimately when we're factoring, we're going to be using the zero product property, which basically says if I have a number of things being multiplied together and I end up with 0, then one of those things being multiplied to each other is going to be 0. It has to be. It doesn't work with any other number. If I multiply and get 0, 0 has to be one of those numbers in the multiplication. That's just a pure, simple fact. It's the only way to get 0 as a product is to have 0 as one of the things you're multiplying. So either x plus 3 is going to equal 0, which means x equals -3, which we already knew is one of our answers. If x minus 4 equals 0, then x equals 4 is one of our answers, which we already had. Or 4x squared minus 3 would equal 0, which means I would take that equation, add 3 to both sides, divide both sides by 4, and then take the square root, giving me x equals plus or minus the square root of 3 over 2. When I take the square root of a fraction, I can take the square root of the numerator and denominator separately, and therefore there are my answers. I have -3, I have negative square root of 3 over 2, positive square root of 3 over 2, and 4. Those are my answers.